Right. So just to let you know, the topics that we are going to be talking about from here onwards, it will be falling under the second half of Sec 3 syllabus. So what are they? For this one, you have kinetic model or kinetic particle theory. All these are similar. The names are similar. Okay, so this is what we're going to be working on. Then after that, we'll have thermal transfer, which is similar to heat transfer. Harold, do you do heat transfer in your lower sec? Have you heard of it before? Conduction, convection, radiation. Yeah, so that's one. I would say like it's sort of like a continuation or rather a repetition from Sec 2. If you're very familiar with the topic, then this should be fine for you. The last one we have thermal properties of matter. So 3 of these topics will then constitute to the second half of Sec 3 syllabus. After you're done, you should be ready for your exams. Just to share. And today we are looking at first one, kinetic model. Okay. So if you look at the first part of it, let me just I'll give you some time to copy down. The first part of the content you see here will be familiar because you will have seen it in your P6 or primary school syllabus. Matter has 3 states, solid, liquid, gas. Samuel has done something about plasma, right?
Yeah.
Do you remember what he did for plasma?
Little bit, yes.
So what is plasma?
Plasma is basically superheated gas, whereby it's so hot that the electrons have gone disappeared.
So there will be plasma here as well. There will be 4 state, but we don't do that because you don't see plasma every day. Simple as that. So the kinetic model is based on the fact that if you can model every single particle as a ball, how will it look like? That's the idea. You know, if you have a box filled with balls used to represent solid, how will it look like? If you have a box filled with balls used to represent liquid, how will it look like? If you have a box filled with balls used to represent gas, how will it look like? So, in short, if you want to understand the meaning of kinetic model of kinetic particle theory, it would be learning about how the balls will behave in a box in different states. Now, is it what's actually happening in reality? No. In reality, depending on the size of the particles, certain things can happen. So we have other models as well. For contrast, for the sake of contrast, we have something called the quantum model, which is when you have really small particles, size of electrons. All right. Then you need the quantum model to explain certain things. But we don't talk about that here. We talk about kinetic model, which is based on what we see around us, things that we can see with our eyes. Example, the table that you are using right now, the chair is sitting on, the air that we are breathing. We can use this model to understand the states. Okay, but we cannot use the model when it comes to really small things like that will be the quantum model, something that you may or may not be learning if you're going to JC. If you are doing engineering, you'll likely be learning about that as well over time. Yay. My personal favorite is quantum model because there's a lot of things to talk about. Okay. So the next part then would be, since you have understood about solid liquid gas, how will the balls behave? So for solid state, think of the balls behaving as if they are vibrating. So you see here, the balls are all stacked up very nicely and they are vibrating at their fixed position. They cannot go anywhere. It's like you right now, you're stuck in your seat. You cannot go anywhere. Okay, unless the lesson is over, which is very, very soon. Okay, you're stuck in your seat, you can't go anywhere. You are vibrating about the fixed position. So imagine you're in solid, this is how you behave. You'll be very, very strongly attracted to your neighbors. So that will explain why you can't go anywhere. Okay, and for the arrangement, you have a regular pattern. As you can see here, you've got nice rows and columns arranged in a very neat way. So that would tell you that it's a solid. And the last part, the distance, is very closely packed together, as a solid should be, because solid are meant to be compressed. Okay. Have you seen it before, Harold? In your Sec 1, Sec 2, anything similar to this?
Yeah, I've seen it in chemistry.
Okay, that's very good. So you're familiar with all this stuff. But no one really told you that kinetic model is about balls, is about circles in a box. Yeah. So the idea is to simplify things, how things behave on a microscopic level by representing them as balls or circles. Okay, so you can read the rest. I think this will be easier for you to understand. Then the properties here, you can actually use kinetic model to explain. All right, again, once again, this is about primary school science. You were expected to memorize this, but now you are expected to explain. So there's explanation here as well, which we will talk about later on. Okay, we are done for this part.